Hi folks, Joseph Kursky here with you to dig deeper into earthquake plate tectonics analysis, level 2. In the first level, we basically opened an ArcGIS online map that had an oceans base map and 6 different layers: plate tectonics, plate boundaries, earthquakes, volcanoes, and some fault lines and stuff like that. Great teaching resource. In a way, it's a digital equivalent of a big thematic map. I used to work at the U.S. Geological Survey, for example, and we had a big thematic map called This Dynamic Planet, okay? And I would lay that big old thing on the table, and we would gather around, and you could teach with it, right? Any geography or earth science instructor could teach with that map because it was rich and engaging, and with the right questions posed, the students were very engaged, and we uncovered the relationship between earthquakes and volcanoes, earthquakes and plate boundaries, talked about tsunamis, mid-ocean ridges, and so on. Now, in the level 1, the digital version of that, it's the same kind of thing, in my opinion. You could open that web map, you could teach with that with a projector and a single computer, or the students could be on their multiple devices, okay? You could actually teach with the digital version of that This Dynamic Planet paper map. The advantage of doing that in a digital mode, if I may be so bold, is that A, you can update it. It's updated daily from earthquake feeds. You can change the scale. The students can actually work with it on their own devices. They can add data to it. They can add cities, for example, and which cities are near coastlines, and look at the population of those cities and so on. There's more you can do with a digital version of it. Not that that paper map is obsolete. It's still a valuable resource. It's a snapshot in time, sure, as to when that map was printed. I think the one I'm referring to is right around 1985 or so. But still, it's a good resource. Always has been, always will be. But the digital version just has its advantages. And in this level 2, I'm hoping that you'll see that the advantages extend far beyond just having a digital version of a paper map. And it's not just having it in a computer that you used to have on paper. You can do more with it. Why? Well, you're not doing it just because it's there, just because spatial technologies are there. You're doing it because it's adding value to your curriculum, that it fosters spatial and critical thinking in a richer, deeper way than you could do with a paper document, okay? So I'm hoping that will be evident through this level 2 especially. So, first of all, with level 2, any data table, the I part of GIS, remember the G part is the map, the I part is the information behind the map, can be sorted much in the same way that any table in Excel can be sorted. So this can be helpful, for example, in examining Earth-related phenomena. Let's go ahead and get that earthquake map pulled up with your 6 layers and your oceans base map, and open the data table for earthquake depth. Click on the depth field and sort descending on this field. So the deepest earthquake is in kilometers underneath the surface, always important to know the units that you're using, appears at the top of the table. And then click on the row corresponding to this deepest earthquake, as shown here. How deep was this earthquake? Does the depth surprise you? Note in the example that there were at least one other deep earthquakes in close proximity on the same day, and another a few weeks earlier not far away. Is that the case with your deep earthquake? I mean, the one I'm looking at right here, it was as of the time that I actually did the screenshot. That changes. So there may be aftershocks and foreshocks on the day that you examine this, and there may not be. Thus, you can use the map to examine these aftershocks and foreshocks. Once your row is selected, use the 3 lines tool to the upper right of the table. Go to Center on Selection as shown here. Once you've centered on selection, your map will show a cyan-colored box around your selected points, for example here. Use the Zoom In tool, +, or use Shift and drag a box to zoom in on this earthquake. Or you could use the Place Names Finder in the upper right to zoom into a place, like Fiji, for example. Is the earthquake over land or in the ocean? In which country is it located? Or which country, if in the ocean, is nearest to it? Click on the earthquake to display the pop-up where you can find more information. The pop-up is pulling information from the table you have been examining, and its contents can be customized. Using the same technique, you can sort and examine, say, world cities by population, soils by pH in your region, and much more. Here, use the same techniques of opening the table, sort descending, and select one or more records in the table to examine the elevation of volcanoes, field ELEV, E-L-E-V. In which continent are nearly all of the tallest volcanoes in this dataset located? Spatial thinking. Use change style now on your volcanoes data layer to symbolize the volcanoes by the type, simple type, as shown here. What are the most common types of volcanoes? According to this data set, and this is a phrase that you should practice using as you teach with spatial technology, according to this data set, meaning that it has limitations and it has benefits, there is only one volcano in Australia, again, according to this data set. In which state of Australia is it located? Zoom to it and click on it to display its pop-up. Now, let's talk for a moment about data quality and resolution. According to Geosciences Australia, this is a volcanic province in southeast Australia called the Newer Volcanics Province, which is a collection of volcanoes, almost 400, covering a 15,000 square kilometer area. The most recent eruptions were around 5,000 years ago at Mount Shank and Mount Gambier. Probably not pronouncing that correctly. The area is considered dormant, which means it is not currently active, but could become active at any time. In keeping with our module themes of being critical of the data, change the base map to imagery with labels for the Gambier region. Use the search box to search and zoom to Ararat, Victoria, Australia. Note that the location of the volcano lies some distance, you can use the measure tool here, southeast of the volcanic region as indicated on the satellite image. The reason? The volcano dataset is a small-scale dataset covering the whole globe. Here, you're examining a large-scale satellite image base map with a component, one volcano, of small-scale data, akin to sort of mixing apples and oranges, if you know what I mean. The global volcanoes layer was collected at a certain scale, zoomed way out, small scale, and this volcano, if collected at a larger scale, would have been placed on top of the image showing the volcanic landscape. On that same theme, if you zoom in on one of the plate boundaries, you will see that the plate boundary's 4 types and the Earth's tectonic plates map features do not exactly coincide. They were collected at different dates with different purposes. Furthermore, they are not mapped in the same way as roads or political boundaries, but rather are determined from geologic measurements, including the frequency of earthquakes as you are examining here. In other words, there's no survey vehicle on the ocean floors, right, saying, well, this is the Pacific plate and this is the Indian plate, etc., right? It's all determined based on earthquake epicenters, really, and some ocean floor measurements to be sure. Finally, on that same theme, use bookmarks, go to California, and make the earthquake faults layer visible. Note that this layer only covers the southwestern part of the USA and was collected at a much larger scale, showing greater detail than the plate boundaries layer. Zoom back out to the whole world. Bookmarks world is a fast way to do that. Change the base map back to oceans. Let's analyze magnitude. The earthquake by depth layer is already symbolized or styled by depth, but as you can see, the earthquake by magnitude layer is only symbolized by show location. It simply shows where the earthquakes have occurred. You have used the change style tool several times in this module, so here, without any further instructions, use the change style tool on the field mag, or magnitude, to make a map where the earthquakes are symbolized with a larger symbol for earthquakes with a larger magnitude. Hint, a map of counts and amounts, size, is what you're looking for. When done, your map will look similar to this. Examine your resulting map. Do the patterns surprise you, or do they fit your hypothesis of the distribution of earthquakes by magnitude? Which plate boundaries seem particularly susceptible to large earthquakes? Why? Using the table, sort descending, and center and zoom on selected tools that you used earlier for depth. So see if you can determine where the largest earthquake in magnitude over the past 30 years was located. So again, sort on magnitude, select that row, and then zoom to it. Another relationship that you could examine is the inverse relationship of frequency of earthquake compared to the magnitude. you could change style and create a custom classification with the breakpoints of your classes at 3, 4, 5, 6, 7, and 8. Remember that your data set only contains earthquakes at 2.5 magnitude and above. So what I'm getting at there is you've got more earthquakes at smaller magnitudes and fewer earthquakes at larger magnitudes, which is a good thing, right, folks? You wouldn't want to have more earthquakes at larger magnitudes. As you could have done earlier after the level 1 earthquake analysis, you could stop your instruction at this point now that you've completed level 2. But in the next, you know what's coming next, right, folks? In the next component, I'm going to have you dig into level 3. Don't get scared. It's going to be fine. It's just going to be a little bit deeper dig into some of the tools that you can use. And as you can see, you've only got a small handful of tools at your fingertips here. You've got some sorting, you've got zooming and panning, you've opened the table, you can run analysis, etc. But there's not like hundreds and hundreds of tools. So by mastering just these few, you're going to be good to go. And you're going to be investigating all kinds of different phenomenon along the Earth's surface, under the surface, and over the surface. Weather, climate, etc. So let's dig deeper now into level 3 in the next video. Thanks.